Hello, I'm Leo Han, and today we are diving into how to deal with the food waste problem in Hong Kong as part of our innovative thinking for organizational design development assignment. According to the recent waste statistic conducted by the Environment Protection Department in 2021, Hong Kong generates more than 16,000 tons of municipal solid waste that ends up in our landfill every day. In our quest to understand and address this issue, we have embarked on a journey of research, employing a mix of methodologies like desk research, online and field research. We will employ the design thinking process theory in understanding and providing solutions to tackle this complex problem of food waste in Hong Kong. The design thinking process was invented by Herbert A. Simon in 1969. It is a methodology that has been widely adopted by various fields such as architecture, engineering, and user experience designs. And there are 5 stages in the design thinking process: empathize, define, ideate, prototype, and test.
To truly understand how big the food waste problem is, we dug deep into the roots by decoding municipal solid waste statistics. Food waste, accounting for more than 32.4% of all municipal solid waste, stands out much more than plastic and paper. Hong Kong's per-person food waste is double that of Singapore, Japan, and South Korea, while our recycling rates fall far behind other Asian cities by a significant margin. Food waste goes beyond sheer volume. It wreaks environmental havoc. Dumping biodegradable food waste in landfills not only takes up valuable space, but also generates methane, a potent greenhouse gas that's 87 times more harmful to the atmosphere than carbon dioxide CO2. This highlights the urgent need for a fundamental shift in how we manage food waste.
We will be concentrating on 4 main strategies as we examine the tactics used by the Hong Kong government to reduce food waste. Food reduction, food donation, food waste collection, and waste recycling.
First up, food reduction, a proactive step at the source. In 2021, the Environment Bureau launched the Foodwise Hong Kong campaign, urging businesses and industries to cultivate a waste-less culture.
Now, moving on to food donation, it is supported by the Environmental Protection Department through the Environment and Conservation Fund (ECF). This initiative aids non-governmental organizations in executing food donation projects. In 2021, the Environmental Protection Department (EPD) rolled out an extensive pilot scheme aimed at collecting food waste. This initiative covers private and public premises. The collected food waste is then transported to Oak Park for treatment, where it will be converted into biogas for energy. The first Organic Resource Recovery Center, Oak Park 1, was constructed with the mission to converting food waste into biogas through the utilization of anaerobic digestion technology. This process produces electricity, and the process residues are transformed into compost. The daily capacity is 200 tons per day at Oak Park 1. In the define stage, we will use the 5 why methods to help identify the root cause problem of the food waste crisis in Hong Kong. The first question asked is that why is there a food waste problem in Hong Kong? Well, because of inadequate public awareness and education on proper food waste sorting and disposal. Why is that? Well, because there is a lack of comprehensive educational campaigns and initiatives to promote responsible food waste management, because of insufficient government funding and commitment to waste management education programs. And why is that? Waste management is not prioritized in the government budget, and there's a lack of awareness about the environmental impact of food waste. So why there is a disconnect between the policymakers and environmental advocates and the general public, leading to a failure to recognize the urgency and significance of addressing food waste issue. Based on the 5 why methods, we have found the root cause is the disconnect between the policymakers, the environmental advocates, and the general public, leading to a lack of awareness and insufficient public funding for comprehensive food waste management and education and initiatives. In the define stage, we will use personas. Personas are detailed fictional user profiles that designers use to create, understand, and address the specific needs and the problems facing each individual. Meet Jennifer, a dedicated housewife with a decade-long commitment to environmental causes. As a devoted vegan and advocate for recycling, she's creating a sustainable home for her two young children, driven by a deep love for the environment and their future. Jennifer's pain point is the limited recycling infrastructure, making it difficult to dispose of recyclable food waste. Instead, all her food scrap goes straight to the garbage bin.
A survey was conducted with 9 participants. While awareness of the issue varies, recycling habits range from rare to daily. Most participants have encountered information about current strategies, but opinions on effectiveness are predominantly negative. Disposal in regular trash is common, highlighting an area for improvement. Interestingly, there's a willingness to adopt innovative solutions. Opinions on community based solutions vary. Participants feel there's not much government contribution. There's a gap in the awareness of the environment impact. For those who compost, community programs are preferred. Views on government support are varied. Despite this, there's a positive willingness to participate in community initiatives. Welcome to the next phase of our design thinking process. After identifying the core problem, we are now focused on generating 3 innovative solutions. This stage involves thinking creatively and using methods like root cause analysis. We aim to develop 3 forward-thinking solutions using the latest technology. This effort is dedicated to addressing the current food waste challenge by enhancing the current recycling methods and practices. Our first solution is called the Eco Bin. It is a cutting-edge smart household bin specifically designed for home composting. This innovative solution aims to transform food waste into nutrient-rich compost through an anaerobic composting technique. The EcoBin mobile app monitors real-time decomposition status, providing users with valuable insights into their composting efforts. It features real-time updates on temperature, moisture level, and decomposition status for informed compost management. Let's take a look at the pros and cons for our first solution, the EcoBin. It is well suited for urban homes with limited space, allowing residents to compost organic food waste at home. It reduces food waste in landfills. The EcoBin's mobile app provides real-time insights, making composting process engaging and educational for users. It also empowers individuals to contribute directly to waste reduction and environmental sustainability. For the cons, the impact may be limited to individual households, and it might not address the waste management needs for larger communities or businesses. The composting process takes time, and residents may need to manage space for composting materials. And success relies on users constantly using the EcoBin for composting, which may vary based on individual habits. Our second solution is called the BioSort Community Digesters. It is a community anaerobic digester for biogas production with AI waste sorting. This is a community-based anaerobic digestion with a touch of technology. AI-powered waste sorting system and the community-wide benefits of biogas production for energy needs. Our target audience are residential communities or neighborhoods interested in collaborative waste management solutions. Residents simply deposit organic food waste into a centralized bin where AI robotic arm efficiently separate non-biodegradable waste. The sorted food waste undergoes anaerobic digestion, converting it into valuable biogas for renewable energy, benefiting the entire community. The AI waste sorting utilizes powerful sensor, camera, and machine learning to identify and pick out non-biodegradable waste from biodegradable food waste. Real-time monitoring is at the heart of this solution. Sensors diligently track temperature, pH, and gas production, allowing us to make on-the-spot adjustment for optimal conditions and maximum yield for biogas. Anaerobic digestion efficiently converts organic waste into biogas, and the byproduct of anaerobic digestion then turns into nutrient-rich compost. Let's take a look at the pros and cons for solution 2. Pros: AI waste sorting improves recycling rates by accurately separating non-biodegradable waste and minimizing contamination. Anaerobic digestion turns organic waste into resources, creating biogas for energy and nutrient-rich compost. It promotes community participation, awareness, and accountability in waste management practices through a user-friendly hub. The cons: integrated advanced technologies like AI waste sorting and real-time monitoring can require significant upfront investment costs. And in smaller communities or areas with less organic waste production, the benefits of the system might not justify the investment. And the installation of anaerobic chambers and waste sorting technique may not be feasible in densely populated urban areas due to space constraints. Our third and final solution is called the Eco-Digester, a commercial on-site anaerobic digesters for restaurants or food production facilities. The anaerobic digestion to break down food waste and leftover food, converting them into biogas for heat and electricity. Restaurants and food production facilities can process food waste now on site. It produces nutrient-rich fertilizer as a byproduct of anaerobic digestions. Now let's analyze the pros and cons for our third solutions. For the pros, it efficiently reduces kitchen scraps of food waste and diverting them from landfills. It enables on-site processing, minimizing centralized waste management. And it accommodates large volumes of food waste, ensuring scalability and efficiency for various commercial kitchen sizes. And it provides an on-site energy generation through captured biogas, reducing the dependency on external energy source. But the cons: the implementation may require significant upfront investment, posing a financial challenges for some restaurant owners. An automated system's maintenance needs skilled technicians and may create operational challenges. And installing an on-site digester may be challenging for smaller restaurants with limited space. And adopting advanced technology may face resistance and difficulties during the initial phase due to staff training. We are happy to announce that Solution 2, the community anaerobic digesters of biogas production with AI sorting capability, has been selected as the winning solution for how to deal with the food waste problem in Hong Kong. This solution stood out for its innovation and practicality. And welcome to the testing phase of the design thinking process. Step 1. We'll begin with the preliminary assessment to ensure the readiness of our system. We will verify the installation, check the AI algorithm, and confirm seamless integration. Step 2. AI waste sorting arms. Here we'll assess the accuracy and the efficiency of waste sorting by introducing a variety of waste items to test the AI sorting capabilities. Step 3. Anaerobic digestion process. Here we'll validate the effectiveness of the aerobic digestion process, introducing organic waste into the anaerobic chambers and monitor the digestion process. Step 4. Real-time monitoring. Here we will confirm the functionality of real-time monitoring sensors and record data on temperature, pH levels, and gas production during the digestion process. We will test the system's responsiveness to adjustment made based on real-time monitoring data. Step 5. Community engagement platform. Here we evaluate user interactions and community engagement features. We invite residents to use the food waste collection bin to track the waste contribution and gather feedback on the platform's usabilities and effectiveness. In the last testing phase, we will identify the areas for improvements, analyze the results of testing phase, and gather feedback and implement necessary adjustments and improvements based on the testing outcomes. In addressing the food waste problem in Hong Kong, we have investigated the composite of municipal solid waste that ends up in landfills every day, containing a significant amount of food waste. We have learned that food waste in landfills generate methane, a greenhouse gas hazardous to the environment and people. By using the design thinking process, the 5 why root cause analysis, and persona, we were able to propose three innovative solutions, each with unique advantages and weaknesses. After careful consideration, the biosort, community composting anaerobic digesters with AI sorting capability emerged as the most viable solution. Its scalability, community-centric approach, and integration of cutting-edge technology makes it a promising solution for revolutionizing food waste management in Hong Kong. Imagine a Hong Kong with a sustainable food waste practices and method shaping our future. Thank you for joining this insightful journey, and I hope you enjoyed this presentation on how to deal with the food waste problem in Hong Kong.